Good morning and welcome. Today we are going to have our fourth lecture in the mini-series. We're going to talk about functions. So let me go ahead and share my screen with you. And we'll get started. So we have been talking about variables and we have been talking about how to assign variable values. And we've been talking a little bit about how to make programs. Today we're going to talk about how we can put that information together into functions to make this a little bit more modular. So this is a bird's eye view of what we're going to talk about. Functions, nuts and bolts. We'll get the purpose syntax and the definitions and some information about how functions return. We'll also talk about some advanced topics about the functions, how we can do the calls of the functions, and the things that the functions cause to have a difference in out in the main program. And finally, we'll talk about some Python built-in functions. So let's get started with the nuts and bolts of how functions work. So what is a function? A function is a block of organized, reusable code that can perform a single action. So we want to think about what the benefits of using a function would be. In fact, it's not necessary to use functions because we could program just the way we've been doing so far. However, some of the benefits of a function would include being able to reuse it. Think about the function on a calculator. What are the functions on the calculator that they can do? Well, they can do, say, addition. So what would it be like if on your calculator you had to actually code up the addition every time you wanted to do it? Isn't it easier to just say, I want to do addition now. These are the two inputs that I want, add those numbers together, and to do that whenever you just needed to do that. So this is a little example of what a function looks like. We'll get into the details of what's actually happening here. You can see that it's pretty simple. It's got a definition, takes some input, doesn't have to, does something, and then sends something back, the answer. This one doesn't send any answer back, but if we had an addition function, it could send back the sum of the numbers, for example. Down here, we have some input information, and we have our function call. It calls that function and sends up some information. So that's the basic way that functions are going to work. We'll delve into that in more detail as we go through today's lecture. So the reasons why functions could be useful, as we just mentioned, can modularize code, can allow you to use that code more than one time. So if you have a similar task that needs to be done at multiple points in a program, you don't want to have copies of the code. Suppose you had a bug in the code and you needed to fix it. Well, if you have multiple copies of that code, you need to fix it in every single place, and that can be error prone. So there's only one place to make corrections, updates, and so forth, which is really helpful. It can also help you to organize the code because it can make it easier to get the big picture of how the program works. When you write code that is organized using functions, it reads more like an outline without all the nitty-gritty details of how those things get done, which can make your code much easier to maintain, much easier to create, and much easier to read. It also allows you to share the code beyond the program in which it is written. So we're not going to really have time to get into calling functions from other programs, but we could recognize the idea that we could import other programs, such as when we do import math, which we'll see in the problem set you're going to work on. And we could use the functions from another program, which means that then you can share your code with other programmers, which is a major feature of how programming gets done. So this is how we would actually define a function. So the functions have two parts. The first thing is the header. This has the keyword def right here, which is going to define the function, and it signals the start of the function. The function name, so you will name your function using the same naming convention we use for variables. Finally, we have the function parameters. So that's the inputs. So if the function is going to, for example, sum two numbers, you might have those two numbers be the input. This particular function is going to print out a statement for you, and it's going to concatenate a string is what it's going to do. So that's the two things it will put together. Finally, we have a colon in the header line, and the colon is simply part of the syntax so that Python knows that it is the end of this line. Notice that the function then becomes indented. That's the body of the function. This is any sequence of statements that do whatever you want it to do. Notice that it needs to be indented. So in Python, indentation is in fact mandatory because that's part of what gets parsed. So it is necessary to indent it, and it will contain, at least implicitly, a return statement. So here is a return statement. That means go back to where it came from. So when you call a function, what happens is the function executes and computes the answer, and then it sends the answer back, if any, to the point which called it. So return signals the end of the function to report back the answer. So that brings us to how to call a function. When you define a function, that only just says, let this be able to be done, but it doesn't mean it actually gets done. And that's something that continually confuses people. In Python, we have a function, which could also be termed a procedure or subroutine, which is like a mini program inside a big program. To call it or invoke it, what we need to do is we need to write the function name, and then we need to supply any arguments that are required for that function to run. So for example, yes, and I'll also mention the number of arguments that go here need to match the number of arguments that were specified in the definition. So if there are no arguments, then this would be empty. If there are 5 arguments, then there would be 5 here, and that goes right back to the definition line. So here's an example of a function. Definition, this function is called greet, and this takes 1 parameter. So when this function gets called, this will get 1 input, and it will need to be the name. So when we call a function, it's going to run the code, potentially causing effects. So what it could cause is a statement, right? So something will happen when the function runs, and that's what we call an effect. It will return a value just like an expression does. So an example of a function and a function call is right over here. This is our function definition, right? Definition, the function is called greet, and then here is the name, and the function will print something to the screen. It will print hello and the name, and then it will return back to the point that called it. So here we are out in the main part of the program. So since this is not inside of the function, we call this main. And so out in main, what we have is a variable called name, and that's set to Professor Bear. And now it's going to call our greet function, sending out the value for name, which is Professor Bear. So when this function runs, what will happen is this will cause this block of code to execute, and then it will greet, and then it assigns the variable name to the value that was sent from this name right here. Then it will print hello and the name of the person, and then that will return back, which means the code will then continue to execute from this point onward. So local variables are important to understand in the context of functions, because functions do not functions operate separately from the main code. The variables that exist inside functions exist only inside that function. So once the function is done, that value doesn't exist anymore. So it's like if you added 2 plus 2 on your calculator, you could imagine that the input would be 2 and 2, right? For that to calculate the answer 4. You wouldn't want the calculator to remember the 2 inputs it did the last time when it calculates 4 plus 5 in your next problem. You would want it to erase those values and start again with the new input. So that's the concept of local variables. The idea is that they are not known to the entire program. They're just sort of like scrap paper, values that are used to get the answer, and then after the answer is obtained, when it gets returned, then you erase the values that were stored to do that calculation. So the local variables of a function are its parameters and any variables defined in its body. The scope or region of validity of a local variable is only going to be inside the function. Once that function is done, the variables don't exist anymore. So if you want to keep any of those values, you'd better save it by returning it. Local variables act like scratch paper for a function. When the function call is over, they disappear, it's gone forever. So for example, here is another function. It's called double, and it takes an input of a number. So here we have a variable called result being defined inside. So this is a local variable because it's inside the function. Number, being a parameter of the function, is also a local variable. So knowing the input number, it will calculate the result, which so happens to be computed as the number plus the numbers. It's going to double the number. And then this function returns the result. So that's great, because if we didn't return result and this function executed, that result would be erased. And so it's like, you know, somebody does the solution on the board and then erased it and you didn't write down the answer. So you have to return the result in order to keep it. And then you can work with it further. Global variables, on the other hand, are variables that are known to the entire program. This is out in main, meaning not inside the function. So in global variables are variables defined outside of any function. They may be looked up, but not assigned from within a function, which is mostly true, where that functionality can be overridden, but we're going to keep it simple. They are not going to, unless you do something very specific to cause a global variable to get overridden. What you want to do is you want to try to assign a global variable from within a function. Instead, what it's going to do is it's going to create a local variable with the same name. So if you have a global variable and a local variable, you have two variables with the same name, that gets very confusing. That's called shadowing and is generally not a useful thing to do. So here we have an example. We have x equals 3 out in main. See, it's not in the function. So that's a global variable called x. Now we have a function called f that takes no input. And we have something here that says x equals 4. So that means that the local variable is equal to 4, but the global variable is x equals 3. So we have two values of x here. How confusing. Now, we're going to use this print statement to ask what the value is. So it's going to print out the local value of x. Notice that the local value is going to precede or overtake the value of the global value. So it will first look at the one that's inside the function, and that's the one that it will use, which is why, even though there are two values of x, this is going to use the local value. Where this gets very confusing is that you may think that the value of x is what it's reporting from inside this function, and then you might leave the function thinking that the value is that, and it's actually not once you get outside the function. So it's very important to understand what's happening here, and it's generally not a good idea to set up this shadowing situation because it gets very confusing. Global variables should be used sparingly. When a function depends on a value, it should generally be passed in as an argument. Global variables are appropriate, for example, when you're doing your final project and you need to play a game and keep track of the total score. That's an appropriate use of a global variable. The current value of the stock market is something that probably should be local and handled inside a function. Global variables are program-wide parameters that would be tedious to pass to every single individual function. So let's actually just take a look at a little bit more code here. So here we have a function called greet with name, and it's going to print hello name, just like we saw before. So here is a global variable called name, and here is a local variable called name. And this function here well, this function call here is going to pass in the global variable name to the local variable name, and then it will print hello name. Now, let's consider a variation of this. So here we have out in main a global variable called name, which is set to Professor Thayer. And now we're going to call the function greet again, and it's going to send up the value of name. Now, notice that this up here has the value of x inside the parentheses. So that means there is a local variable called x, whereas in this one we had a local variable called name, which is the same as the variable name that's used out in main. So confusing, right? So first question is it fine to have a different variable name inside the function than what is being sent up? And the answer is absolutely yes. And the reason for that is because what actually happens is the variable assignment happens as part of the call function, the call process. So when you run this line right here, greet name, to send up the value, what will happen is the local variable x will take on not name itself, but whatever the value of name is. So this x never actually knows that that was sent in the variable called name. It doesn't know that. All it knows is just it has a value of Professor Thayer and it assigns that to x. So that's why it doesn't matter that those aren't matched. So then it will print hello and it will work just like this function over here, and the value of x is the same, and then it will return. So this is an example where shadowing is involved because we have two variables, a global one and a local one with the same name. And in this case, we have don't have shadowing because x is a different variable than name, so that didn't happen. So it's perhaps a little bit easier to keep track of the fact that those are two separate variables. Return statements. So all functions have a return statement. It's just not that it's always explicitly written. So when a function runs, we always need to know where it's going to go next, because again, we have to think about algorithmic thinking and execution. When a program runs, it's going to go step by step, and then it's going to go to a particular position, and it needs to know what to do next. So the return statement is always going to be the thing that causes the function to end and to go back from where it came. A return statement aborts the execution statements within a function body. So if you put a return statement in the middle of your function is going to end early. Sometimes you might actually want to do that. And when we get to if statements, you could see that once this criterion is satisfied, like if we already know the total sale, we could stop adding stuff, right? So that would be an appropriate use of a return statement in the middle. But generally speaking, you probably want your return statement to be at the bottom of the function. The value of the expression following the keyword return is going to be returned to the function's caller. That means you can actually do a variable assignment as part of calling the function. So that it's like, you know, if you do 2 + 2 on your calculator and you press enter, you expect it's going to give an answer out. So you might want to store that value inside a variable. And in Python, if you do not store that value inside of a variable, it will not be usable again. Now, some functions don't actually need to return anything because maybe their job is simply to print a greeting to the screen, for example. So there's nothing like an answer to give back. It already did its thing. So if you return and you don't have anything after it, then it's returning nothing. So return none is assumed. This brings us to something that is also a little bit confusing. If the function body ends without a return statement, then return none is going to be assumed. So it's the same as return none if you don't actually put it there. The key thing to take out of this is that all functions must return something. It's just some functions are not returning anything, any content. They are returning like an empty placeholder is basically a good way to think about it. So that brings us to this none and none type. So in Python, there is a type with exactly one value, and that type is called none type. And only value that is called is none. So that's when we need to return nothing. And so in Python, we need to actually have that placeholder there. And this is it. It's the none type. So the type, so none is the thing that gets returned, meaning there's no value associated with it. and that has a very particular type. So remember I said we would meet more types in Python. Well, here's an example of another type. The type is none type, and the only thing that can equal it is none. So when we have a function that doesn't return anything, right, it just prints some stuff on the screen, means there's no answer to give back. The function itself is going to return none, and the type of none is called none type. Confusing, I know. You just have to practice with it and stick with it. Eventually, hopefully, it will make sense. The none value provides no information, so the Python interactive interpreter suppresses printing it, which is why when you run it in interactive mode, if you run a function that returns none, you won't actually see anything. So this is a flow of program and functions to help you understand how functions can change the flow of a program. So let's consider this program on the left, read linear. So here we have name equals Professor Thayer, and we print hello and my name. So this program reads comment, 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 then it does the variable assignment, and then it prints. So we see that this program executes from the top to the bottom. Let's see what happens to the flow of how the program executes in the event that we in fact have a function call. So here we have a function, okay, so it goes in and it always starts at the top, right? So program starts at the top, reads comment, comment, comment. Oh, let me learn how to do a greet, okay? So that doesn't mean it executes it, it just only is going to learn how to do it. So it says, oh, if I get greet call, this is what I should do. I should look for an input variable, and this is, I should print hello, and then I should return. I should do that when I get called. I'm just learning how to do it, but I'm not going to do it right now. Then we go down here and we have, oh, it says, oh, variable equals Professor Thayer. So we're going to set name equals Professor Thayer, and we set up the variable table for that. Great. Now we go to the next line, and it says greet name. So now it says, oh, function call. Okay, so now I need to move to wherever that function is. So the controller is going to move from greet, this command here, up to the actual program, the actual function that's doing this. Name is the value that is being sent. So name evaluates to Professor Thayer. So that's going to send that up. So we go up to here. Here we go to our greet function, and a variable assignment will occur. Name will be assigned to the value that was sent, which is Professor Thayer, because it was set up to do that right here. Now it's going to print on screen hello and the value that it has for name, the local variable, and then it returns, which means the control or the flow is going to move back to the end of this line, which is what called it, and that's it. So you see that the output of these two, which I've shown beneath, is exactly the same in both cases, but the program flow is really quite different. So it's important to understand the difference between returning and printing a value that is returned from a function is available for further use within the programs, because that actually sends it out. Now, just because you return it doesn't mean it's usable. You have to catch it in a variable. So it's kind of like baseball. Now, I'm not really too into sports, so you have to excuse my my lack of understanding of sports, but we'll get the basic idea. So if there are there's a pitcher and a catcher, all right? So the pitcher, which is out in Maine, has a ball. That represents the information that's being sent in to the catcher, which is going to represent the function. Now, the pitcher can throw the ball and have no secret message written on the ball, which is like having a function that doesn't require any input. So if the function always prints A, then it doesn't require any input because there's no variable, there's no variation in it. Now that's a pretty boring function. So maybe instead of printing A, maybe the function is going to print hello and the person's name, but we would need to have that input information. So what if the pitcher took out his ball and he wrote a name on the ball, right? And then he takes that and he throws it to the catcher. Okay, and the catcher catches the ball and says, oh, I have some input. It says Professor Thayer on this ball. I must greet Professor Thayer. Okay, and so then it greets Professor Thayer on the megaphone and then erases the secret message on the ball. Now, there's nothing really to send back because the function is done, the greeting is done. So now that has nothing left, but the control still needs to go back to the other player. So we take the ball and we throw it back with nothing written on it. Okay, so that's an example of how the flow passes. So the ball represents the flow, and what we write on the ball represents the information that gets passed. Now let's consider another option. The pitcher needs to know the answer to a math problem. So the pitcher says, I have to compute the sine of 19. And I can't do it in my head, but I know you know how to do it. So I'm going to put sine of 19 on this ball. And so we're going to have 19 as the input. So we'll put that on the ball, and then he throws it out. Okay, and the catcher catches it and says, ah, I know how to take the sine because that's my job. And I see the input is 19. So let me just calculate up the answer for you, sir. Erases the answer, the 19 on the ball, and then writes in the answer, blah, 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 which I actually don't know off the top of my head. We write it in, blah, blah, blah. Okay, and then, now that ball now has the answer. And so you take the ball, throw it back to the pitcher, and the pitcher gets it back and says, ah, that's the solution. Now I know how to calculate how to win the game. Okay, so the pitcher says, great, information. But now if that pitcher never actually read the information and stored that in the brain, then that information would be lost forever. It would be like if somebody wrote the answer on the ball and just, I don't know, threw it away. Put it in, send it to somebody else, right? It would not be helpful because that information would be lost and the pitcher wouldn't have gotten the information he needs to know what to do. So in order to capture that information, what we have to do is we have to store it in a variable. And so what we do is we write the variable equals the outcome of executing a function. And that's how we can store that information. So we have to think about how the information travels. There is parameters that get sent in with the function call, which are whatever the information the function is expecting. And then the function, having that information, calculates something. And if an answer is required, then that information needs to be put in an expression after the return statement, which is equivalent to writing an answer on the ball and throwing it back. So then when that information comes back to the thing which called it, then that information is stored in a variable, and then that information could be used again. The information could also be used in a composition, that is to move on and calculate more things. So you've probably seen this in math class and you just didn't realize it. And really what it's equal to is, say you have something inside of a parentheses that you need to resolve first, and then the answer of that is, you know, multiplied by something outside the parentheses. That's an example of where you get the answer first of one part, and then it goes on to the next part, which also works in Python as well. So it's important to understand the difference between returning and printing a value. Returning means you actually send the information back, whereas printing it means you simply just displayed it on the screen, but it can't actually be used for anything. The value that's returned from a function is available for further use within the program. For example, being stored in a variable or being sent into another function. It can be assigned to a variable used in an expression or passed to an argument to another function. But a value that is printed to the screen is lost to the program. It can no longer be examined or manipulated, right? All it does is just show it to the user, not to the program. In fact, print is a function that always returns none. So if you do type of print hi, you will get none. Notice that there is an important difference between these two functions. Both of these functions will double the input n. Okay, so this example of double will return the value of n plus n, which means it can be used again. Whereas this simply just prints it to the screen. So it means that it calculated it and displays it. But if you want your program to do something with it, like use it to calculate the cost or use it for some further evaluation, it will be unavailable. So the best thing we want to do is we usually want to do return, where we have the value being sent out. If you really do only need to display it, you can use print. But in all the other situations, you should be using return. Instead of storing the value returned by a function in a variable, it can instead be used directly in an argument to another function, and this is called function composition. Function composition is using the output return value of one function as the input argument to another. So here is an example. This is a function that does not have composition, so def double x. So this is going to return 2 times x. So y equals double of 5. So this calls the double function and doubles 5, which is 10, and then prints y. So this has a variable, and then we print the value of that variable. So there is no composition here because the value that gets returned is stored in a variable, and then we print the variable. Now consider an alternate way of doing this, where we have again the same double function that returns 2 times the input. Now look at the difference here. The difference is out in main. So here this does double of 5 to get 10, and then that gets printed directly without the use of the variable y. So this is great if you in fact only need to do one thing with the value that gets returned. So if all you need to do with it is print it, then this will work. If you need to do more things, like maybe you need to, once you know double of 5, you need to calculate the cost to buy, I don't know, two pairs of scissors, for example, right? You might need more lines here. Okay, so it can be a useful shortcut when you only need to do one thing, but if you need to do multiple things, you need to do this form here. So that brings us to our concept check. Identify the functions over here. So let's just go through the questions, and then I would recommend that you pause this and actually try to answer these. So you see we have some functions over here, and the idea is you should read through these functions and try to figure out what they're doing. So my questions to you are, can you identify the functions? How many functions do you see over here? In each function, identify the key parts, the definition, the local variables, and the return statements. Keeping in mind, not all functions explicitly have one. Where are the function calls? Where are the local and global variables? Trace the flow through the function. So go ahead and pause that and see if you can answer those questions, and then I will see you back in a moment. All right, so I hope you had a chance to read through these. Let's just go over the answers to this. So the functions we can identify because they begin with def, so there are in fact 3 of these functions. In each function, the key parts are the definition, right? That's this line here, the top line on each of these. And the local variables in this function are going to be the input parameter and length. Again, here, the variables which are being input are going to automatically be local variables, same for this. And then any variable that's defined inside. So width, for example, would be another local variable. Horizontal, vertical, and area would be local variables to calc area. The return statements, we can see here is a return length, here is a return width, and here is a return area. The function calls are found down here. So this is a calc area which calls this function here. Now notice that there is something interesting going on here, that there is actually there is actually a function call inside of here. So here we go. Calc length right here you see is another function call. So this function is the calc area function is calling the calc length function, sending up side 1 and dimension x as the input variables for this function. There is another one right here which is calling calc width. So we see that function calls can occur out in main, but they can also occur from inside of a function. Now, let's trace the flow through the function. So the original function call that will execute, remembering that reads linearly, but it does not initially execute these, is right here. So calc area is the first function call, sending out values for side 1, side 2, and dimensions x and y. Calc area will run first, so even though there are multiple functions above it, this one is the one which is called first. These variables get assigned to these values, and then we have another function call. So the control goes up to this function, which calculates the length and sends that back to go into horizontal. Next comes vertical, and this does another function call to calc width, which is right here, sending up the side 2 and dimension y values, and this function then returns the width value into vertical. Then area is calculated by multiplying these two answers together, and return area then returns the flow back to the thing which originally called this one, which is down here, and then this is sent into the print function, which prints the final area. Notice that this is an example of composition because this is an example of a function being called, calculates something, and then that value is sent back and that goes into the print function, which prints it. The alternate way could have been storing the answer of calc area into a variable, and then we could have printed that variable. All right, so the other thing I want to talk to you about today is the Python built-in functions. There are a number of them that you've already been using, plus a couple of others that we haven't seen yet that are very useful. So some familiar Python functions are type and print. So type is a built-in Python function that takes an expression and it will return the type of an expression to the caller, and print is something that will print the textual representation of an expression to the screen and returns none. Input and output functions. The print function takes an argument and has the effect of printing the value to the screen. We may also want to take input from the user, just keyboard, and give it to the program. The input function does this. So suppose you want to pause your program and say, what is your name? Right? We need a way to get that information into the program, and that's what input does. So input will take whatever the user types, and then it will return that to the program. So if you store that in the value, then we can use that information. So for example, here is the input function, which will return whatever the user types into a variable called name, and then it gets into the program and we can print that to the screen. Coercion functions. So we have kind of seen this already. We've seen that Python sometimes converts one type into another, even when we didn't expect it to do it. And so that means that under the hood and behind the scenes, Python is converting one type to another type. This happened, for example, when we did print and we gave a number, because print, in fact, only will print a string. So when we did print 5, for example, the 5 was converted into the string representation of 5, and then it was able to be printed, and that happened because the coercion function was called. Now, the coercion functions basically will attempt to change the types. It will take a value, and it will take one type and try to make it into another. So the coercion functions, in fact, actually just take on the name of the type that they're going to try to make it into. So string of some expression, we'll try to make it string, int will try to make it int, float, bool, as expected. Now, whether or not it can actually do that is going to depend somewhat on what the type actually is. And sorry, I apologize, it looks like my box moved here. But anyways, the basic idea here is that if we try to do string of a number, that will be fine. You can basically represent anything as a string, but if you try to do int of the word dog string, there is no integer representation of that, so that would cause an error. Other things to be aware of is integer will do a truncation, right? So, okay, so here we go. Here, int of hello, right? Doesn't make any sense, so we get an error. You can't do that kind of a coercion. But could you make an integer value out of 3.999? Yeah, you can, but it's important to understand that what it's going to do is it's going to truncate it, and there's no rounding. So you might expect that that would go to 4, but it doesn't. It's just going to take whatever number you have. Boolean of false. Yeah, this is, the Booleans behave very strangely. So basically, everything is going to evaluate to true because this is a string. So the Boolean of any string is going to simply just evaluate to true. Boolean of the value false will evaluate to false. Boolean of my string will evaluate to true. So they don't always behave exactly as you would expect, and that's why when coercion is happening behind the scenes, it can be a little bit dangerous, but it can be useful. Okay, so here we have a couple more examples, right? So again, you can't convert words, and these are actually basically the same examples that we just saw. So implicit coercion means that if an expression has a type different from the one expected, Python may silently try to convert using a coercion function, always being so helpful, although at times maybe it's not. This can be a source of problems in your programming code, as Python is trying to be helpful and may do something you didn't really want it to do. This is called implicit coercion. The print function expects a string argument, and if it finds something else, then it silently calls string on it. So print 2 plus 2, 2 plus 2 will resolve to 4, which is type int, and print cannot do anything with an int, so it's going to call str on it, and then it will convert it to the string representation of 2 plus 2, which of course is 4, so that it will report 4 on the screen. So that's an example of implicit coercion because you didn't actually ask Python to do it, it did it all by itself. So coercion in Booleans, as I've alluded to, may provide some unexpected results. So Booleans have the property that they can be coerced into integers. True is 1 and false is 0. Overloading of Booleans is in mathematical expressions allows some conversion of true and false, which is a very useful use of them. So some mathematical operators are overloaded to allow working with Booleans, and the Boolean is coerced to its integer equivalent. The operation is then carried out. So we can have these really bizarre things. So we could have true, which is equal to 1 plus 2 will equal 3, which if you didn't understand that it was undergoing coercion, you would be totally mystified by how that happened. Okay, now we can have 2 minus true, which will give 1 with this substitution. Multiplication, true times 2 will give 2, and division, 3 divided by true will be 3.0, of course, because there's also the coercion into the floats always occurring. Now we can also do the same thing with false, where that's going to be equal to 0, and of course in this case this will cause a problem because division by 0 is undefined. Python math functions from a module. So to access pre-existing functions in Python, you can use the import command and the name of the module containing the functions you wish to use, such as import math, which will then allow you to use a whole bunch of math functions. Math module allows you to access additional math functions such as sine, cosine, tan, and pi. To call functions, you type the name of the module, a dot, and the name of the function you wish to use. So for example, math.log10 100 will give you the logarithm base 10 of 100. So we will actually practice with the math functions in this week's labs. The math functions work a lot like a calculator, just you need to remember to use the math dot to use that dot notation. Composing functions with the math module. So we mentioned composing functions means having one function and the answer of that function being passed on to something else. So it's sort of like using parentheses. So we have 5 times 3 plus 1. We would realize we first redo 3 plus 1 to get the answer, and then the answer that gets sent into the 5 times, right? So this is an example of composition that we would commonly use all the time, because this gets parsed and then it's sent on to the outer thing. Now we could have x equals 3 plus 1 and then 5 times x. That would be writing it out, but we can do this, which is much more compact. So here is an example using composition with the math module. So this is going to first do the square root of 4, which will be 2, and then this outer function will take the value 2 and it will take the sign of it. And so that does it all in one step. Dynamic typing is the idea in Python that a type of a variable could change throughout the program. Now this is something that deviates from many of the other original programming languages where types are not changeable during the program. So every variable has an associated type, which is the same as the type of its expression. The types may be able to be changed by using the coercion functions. Sometimes it's invalid, but many times it can be done. The same variable may have more than one type in the same program, which is the dynamic typing, because what it is dynamic. Although it's possible, this should definitely be used with caution. Knowing the type of your variable at all points of the execution of your program is important. So here we have x equals 5 and we ask the type and it says it's int. And then we could do a coercion on that. So we could do float of x on that and save that into x. So this is dynamic typing because x used to be a type int. And now we see that it became a float. Here is some practice problems for you to try. Rewrite the print statements to make any coercion explicit. What will Python return and what will any make any errors? So I would encourage you, if you're watching this video, to go ahead and pause this and try this on your own and then join back with us to see the answers. So here are the questions we had from the previous page. And so we do print 2. This is going to coerce it into a string. And so we do the coercion explicitly. Print float 2 really means doing string of float of 2. Printed 2 plus 2 is really taking string value of 2 plus 2 to print 4. In this case, we have multiple things. We're going to have int of 2 and float of 2 and add those together, which will implicitly call float, right, which will then cause the whole thing to become a float. And then once we get the answer as a float, we need to call string to actually print it. Now, this one causes an error. What's going on here? So if we have string of 2 and float of 2, this addition is not defined. So that, of course, isn't going to work. And because when we actually put that all out with the explicit strings, we see that makes no sense. You can't convert float object to string implicitly. Here we're going to do true plus 4. So here what we're really doing is we are taking the integer of true and integer of 4, adding those together to get 5, and then taking the string of that. True times false is really, of course, doing int of these two, true times false, which is going to be 0 and 1. So multiplying them will be 0, and then we convert it to a string, which gives us 0. So it can be a little bit confusing. It's important you take the time to make sure you understand how this works, but basically that's how Python is converting the various types. So then that brings us to our summary. We talked about the purpose of functions, the syntax, defining and global and local variables, how to return, and tracing out the flow. We talked about composition and call execution. We traced out the execution of that function. So for call graphs, we had a look at that tile program where we were actually seeing a function call within a function. And we have also seen how to put inputs, right? Specify the inputs and the outputs of the function, and then talk about how that causes changes in the program, for example, displaying something on the screen. We also talked about Python built-in functions, print and input in particular. We also saw the math module, and we also discussed the coercion functions and how they work. So this, in fact, actually concludes our mini program. I hope that you have enjoyed working with me and learning this material. We have another problem set for you to look at. And had you continued on in the full-length class, this is what we would be doing the next time. You'd be having another lab section, you'd have a homework, and also the TA and help sessions would be available. So I just want to say thank you for joining us for these lectures. I hope you found it interesting, and I hope that you've learned a little bit of Python and maybe even convinced you to take my full class. It's been a pleasure working with all of you. Good luck with your problem set. I will be available to help you with those during the office hours, and you also have the opportunity to work with us on those problem sets during Thursday's session. Hope to see you soon. Bye-bye.